Hello student, this is lecture for B.Sc. third year and subject is paper is numerical analysis semester 6. In last lecture we have already discussed what is meant by the finite differences. So here we are going to discuss all differences, first difference, second difference to nth difference. Then we have to try to generalize the differences. Then some notes, and after that we will discuss some problem. So student, so in the last lecture we know that what is meant by first difference, that is delta f of a. So delta f of a is nothing but f of a plus h minus f of a. That means increase this a by h, that is f of a plus h, and minus this original f of a, that is f of a. That means f of a plus h minus f of a is nothing but the difference between two consecutive terms of entries or independent variable. Next, f of a plus h. So what will be the difference f of a plus h? So f of a plus h is f of a plus, so add one more h in this h, so we get f of 2h and minus original term, that is f of a plus h. So this is the delta of f of a plus h. Then delta of f of a plus 2h. So what will be difference of this such term? So we get f of a plus 3h minus f of a plus 2h. So in this way we can find the first difference up to n terms, that is f of a plus n plus 1h minus f of a plus nh. So these differences of these first differences are called second differences. Doing this, all these are the first differences. Now if we have to find the second difference, that will be denoted by delta square f of a. So delta square f of a is nothing but delta of f of a plus h minus delta f of a, because this is the taking again delta. How can we express this term like this? Delta of delta f of a. So we know that what is delta f of a? Delta f of a is f of a plus h minus f of a, and operating this operator delta, so we get del f of a plus h minus del f of a plus h. So this is the delta square f of a. See here how we are writing this delta square f of a plus h. Now we have to calculate delta square f of a. So what is the delta square f of a? Delta square f of a is nothing but delta f of a plus h and minus delta f of a. So this f of a plus h and delta f of a we know from this. Suppose we call this is equation number first, this is equation number second, and so on. This is a third, this is a nth, no, this is n plus 1, anyway, whatever. So we have already discussed. So what is the delta f of a plus h? So delta f of a plus is nothing but this from equation second, delta f of a plus h, f of a plus 2h minus f of a plus h. So I am going to write it. So f of a plus 2h minus f of a plus h minus of delta f of a. So delta f of a is nothing but f of a plus h minus f of a. Now calculating this, f of a plus 2h minus f of a plus h minus f of a plus h plus f of e. Then we get f of a plus 2h minus 2 times f of a plus h plus f of e. So in this way we can calculate delta square f of a. What is delta square f of a? So delta square f of a is nothing but f of a plus 2h minus 2f a plus h plus f of p. Similarly, we can find delta cube. Similarly, delta cube f of a equal to f of a plus 3h minus 3 times f of a plus 2h and plus 3 times f of a plus h minus f of a. So this is the third difference. That means जिस तरह से हमने सेकंड डिफरेंट को कैलकुलेट किया है, बट सेम मेथड से फाइंड डेल्टा क्यूब एफ ऑफ ए. सो डेल्टा क्यूब एफ ऑफ ए नथिंग बट डेल्टा ऑफ डेल्टा स्क्वायर एफ ऑफ ए. रिमेंबर दिस, delta cube f of a. What is delta cube f of a? Nothing but delta of delta square f of a. So we get delta of delta square f of a is this term. So that is f of a plus 2h minus 2f of e plus h and plus f of a. And again using this operator delta, we get this term. I called it as star equation. I call it a star. Delta cube f of a. So similarly, we can find delta 4, delta 5, delta 7. In this way, we get the general term delta fn of f of e is equal to delta n minus 1 f of a plus h minus delta power n minus 1 f of e. Remember this formula. So this is the nth difference. And how can we find nth difference? So delta n f of a is equal to delta power n minus 1 f of a plus h minus delta n minus 1 f of a. Now whatever the value of the n, we get the corresponding values for further problems. Now we discuss some points, some important points. So student, try to remember some notes on different sets. Some notes. So remember first point, what is that? So f of e is first entry. This is the first entry in independent variable. Got it? So this term is called as leading entry. And this difference is delta f of a, delta square f of a, delta cube f of a, and so on, called as leading differences. Called as leading differences. Now you remember this. This is delta is not quantity. That means this delta has no values. Remember. But this symbol stands for operation. So this symbol indicate operation. Which operation should be applied on the function. So this delta is not quantity. It is operation. And this delta square does not represent multiplication. Remember this thing. Or the square of delta. It is not square of delta. That means not delta into delta. It is the times of operation. How many times of operation or how many times this operation used. That number indicate here. Actually this is not like this. 2 square is equal to 4. Okay. Now next point. This symbol is called forward differences. This is called forward differences or descending differences or descending differences. So this is operator and this operator is called as forward differences or descending differences. Again one point is that delta f of e is not equal to f of a delta. That means in short delta f is not equal to f delta. So this is not commutative. This operator is not commutative. This operator must be applied firstly on the f and this delta operate on whatever the thing is there. So try to understand the difference between these. In next lecture we will discuss some examples about the differences table. Thank you.